Let's look at an example. And for instance, we said one of the responsibilities of the operating system is to manage resources like memory. So we'll look at a memory management-based example. To do that, the operating system uses a memory page as an abstraction, and this abstraction corresponds to some addressable region of memory of some fixed size, for instance, 4K. The operating system also integrates a number of mechanisms to operate on that page. It can allocate that page in DRAM, and it can map that page into the address space of the process. By doing that, it allows the process to access the actual physical memory that corresponds to the contents of that page. In fact, over time, this page may be moved across different locations in physical memory, or it sometimes may even be stored on disk if we need to make room for some other content in physical memory. This last one brings us to the third element, policies. Since it is faster to access data from memory than on disk, the operating system must have some policies to decide whether the contents of this page will be stored in physical memory or copied on disk. And a common policy that operating systems incorporate is one that decides that the pages that have been least recently used over a period of time are the ones that will no longer be in physical memory and instead will be copied on disk. We refer to this also as swapping. So we swap the page, it's no longer in physical memory, it's on disk. The rationale for that is pages that have not been accessed in a while, so the least recently used ones, are likely not to be as important, or likely will not even be used anytime in the near future. And that's why we can afford to copy them on disk. The ones that have been accessed more frequently are likely more important, or are likely we're currently working on that particular part of the content, so we will continue accessing them, and that's why we maintain them in memory.